All right, welcome to your next lesson in Unit 3 on expressions, which is properties of addition and multiplication. This is an NIB, which means not in your book. All right, let's scroll up to your table of contents. Go ahead and put your date, and for properties of addition and multiplication, we're on learning goal number 20. So if we look at that, you can see learning goal number 20 says you can identify the properties of addition and multiplication in equivalent algebraic expressions. So you not only have to be able to identify them, but of course be able to understand how they work and create equivalent expressions as well. All right, here are the definitions for these. So we're going to look at the associative property, and this is a grouping property only for addition and multiplication though. So be aware of that little piece here. The commutative property, I always like to think that if I move houses in my community, I'm still part of that community, and that equals the same thing. So again, this is addition and multiplication only that works. Obviously, 4 minus 3 is not the same thing as 3 minus 4. But that does work. 3 plus 4 is the same as 4 plus 3. 3 times 4 is the same thing as 4 times 3. So that's what we mean by that. Distributive property says that when we have a term on the outside of parentheses, we can distribute that to the inside and do 4 times 3 and 4 times plus 4 times 7, and that's the same thing as 4 times the quantity of 3 plus 7. The identity property of addition. So the identity properties of either just means when you do something to the original addend or factor, the original number, it still equals itself. Okay, so we know for addition that special identity number would be 0. For multiplication, that special identity number would be 1. Okay, in order for it to equal itself again. The next one is the 0 property of multiplication, and it just says that anything times 0 equals 0. Okay. All right, let's go ahead and get into the actual lesson. So lesson 3, here we go. So what are the properties of addition and multiplication? Let's go ahead and get these down. So the first one is the commutative property, or the commutative property. Commutative. I think about it as those houses in the community that you can move around. Okay, so you can, it says that you can change the order. Okay, all right. The next one is the associative property. And this is a grouping property. So it says that you can group different things as long as all the things are addition or all the things are multiplication. Any grouping will still equal the same thing. The next is distributive. And this says that you can take the factor on the outside and you can distribute it to the inside. So this is the same as 2x plus 6. Okay? All right. And the next one is identity property. And so we're looking at what special identity can we use to keep the number the same. So we know that any number times 1, okay, for multiplication. So for multiplication, that identity is times 1. And for addition, that identity is plus 0. Okay. So for example, 1x also equals x because anything times 1 is itself. X plus 0 still equals x. Okay. All right. Next is your 0 property. And this is only the 0 property of multiplication. Okay. Because 0 with the addition is the identity property. So this says that any number times 0 is actually 0. Okay. All right, let's go ahead and name the property. You must include whether it's the addition property or multiplication property. Okay, so if we look at these, what we want to be noticing is what's going on in these two equations. So you can see the equal sign here. Okay, so we're looking at what's happening, and I see that there's brackets around the x on the left side, but not on the right. And so it looks like everything else is the same other than moving the brackets. Let me increase the size of this just a little bit. So I can see I have brackets here, and they moved to here. So this is our associative property of addition, because if you look, the operation is addition in those expressions. Okay. All right, next one, again, let's notice what's going on. I have a negative 5 times x equals x times negative 5, so we switched the places of these. Okay, since I switched the places of those, that's moving the houses around in the community. So that's the commutative property. And notice the operation is multiplication. All right, the next one, it looks like parentheses are moving around. But actually, we have the parentheses moving around, and it's all addition. But we also have, so instead of 4x plus 3, we have 4x plus negative 2x. So we do have the associative going on, but it actually looks like we also have some commutative going on here as well, because we have the different addends moving around differently as well. So this one actually looks like the associative property of addition, because that's the operation, but I also see commutative going on here, property of addition. So this one, it looks like it has two properties being shown. All right, the next one, I see the 0, so it's a pretty obvious thing that this is the 0 property. Look at what operation is, it's multiplication. Okay, the next one, we see that, let's see, we had a 4 times a quantity and now it's gone. So this looks like the one where we're distributing the 4 to each of those. So 4 times 3 and 4 times 2x. So this is the distributive property. And this is always the distributive property of multiplication. Okay. All right, the next one, let's go ahead and look at this. I see a 0 plus, and the other one doesn't have a 0, so I'm pretty sure they're representing the identity property, but if we look at the operation, it's the identity property of addition. Okay. All right, and then the next one, we definitely have parentheses moving around. Let's look at the order of the variables numbers. We have b 22.5, b 22.5. So the order is the same, but the grouping is different, and grouping is associative property. What operation? That's multiplication. So that's the process of identifying the properties. Okay, so you're aware of what's going on and how they work, and that it's okay to move them around that way. All right, next they actually want us to use those properties to create a true equation or equivalent expression on the right side. So let's go ahead and do that. They want us to use the associative. Associative, I know, is grouping. So all I have to do is write the exact same thing. So I'm going to write the n plus 0.6 and plus the negative 1/2. And all I have to do is just change the grouping. So instead of n plus 6/10, I'm going to do the 6/10 plus the negative 1/2. So I changed the grouping and with the addition operations. All right, the next one, they want us to show the commutative. Commutative, remember, is moving the houses around in the same community, and that's okay. So all I have to do is something, I could do a couple things. I could move this times 7/8 over to the other side. I could flip-flop the, actually, you know what? It is specific because it's of multiplication. the thing that I'm moving around is this multiplication problem. I can't be doing the commutative with this in parentheses, because that's going to be commutative property of addition instead. So for this one, we're going to go ahead and move the multiplication around and just make it this way, and then leave the addition alone. Okay, so there's our commutative, moving the multiplication around in the problem. All right, and then y equals, so this is the identity property of multiplication. I know that that is anything times 1, okay? So right now there's just a y, so I can say that that equals the same as 1y, okay? All right, so let's go ahead now and we're going to use the distributive property to write an equivalent expression. So we're going to be showing that underneath. What I want you to do is I want you to show the distributive arrows here, okay, to show that you understand that process. Okay, for the one in number 2, you can see it's the -5 that can be distributed to those other factors. All right, so let's go ahead and look at this. We have the 7 times 8, but you have to pay attention to your integer rules, is -56f. And then the -7 times a -5 is going to be 35, but that's a positive 35. Okay, so notice the way that I said that made it so I had to write positive 35. If I wanted, I could have KFC'd that first, okay, to have plus, and it still would have ended up being a positive 35. Okay, all right, the next one, we're doing the -5 times the 3x, so we have -15x plus -5 times a positive 4. I hate to love, so actually hate is a -20. Okay, all right, so let's go ahead to number 3. We're distributing. So remember, we've always been saying that this means opposite, but I've also mentioned to you that it also technically is a -1. Okay, and that's what's making it opposite. Okay, it's a -1 times something. And so that's really what we're distributing here, is the -1 to each of these. So draw your distributing arrows. So I have a -12k plus now a -70. Okay, all right, and then over here, so this time we're actually distributing a negative rational number. And so it'll be a little bit more of a pain in the butt since we're dealing with the fractions. So we have -1/4 times 9k. Remember, this is sort of like 9 over 1k. And so when we multiply this fraction, okay, we end up with 1 times 9 and 4 times 1. And so you end up with a -9/4 times k. Minus, and now we have, I'm going to go ahead and KFC this first. Okay, so we have adding a -20, so we have a -1/4 times a -20. So I'm going to do that work up here, times -20 over 1. We can cross simplify this. Okay, and so divided by 4 is 1. 20 divided by 4 is going to be the 5, but it's still negative. And now I have the -1 times the -5 is 5, and the 1 times 1 is 1. So we end up with plus 5 at the end. Okay, all right, so you can see how you have to be really careful with this. All right, this next section, we are picking a value for x, plugging it in, and then we're going to say whether they are equivalent or not equivalent. Okay, so I'm just going to pick something simple. If you have a choice, don't make it complicated. Even simpler would be to pick something like 1 or 0. So why don't we just do that? We'll keep it nice and simple since we have the option to. So x is equaling 1. First thing I need to do is go ahead and substitute x. Okay, I could put the 1 in parentheses, but in this case, it doesn't really benefit me much, so I'm going to go ahead and leave that off. All right, and then I can go ahead and solve. So 5 minus 1 is 4. Keep the sign of the bigger digit. Plus a negative 4. You can see how I'm bringing down my work. Same signs, add and keep. I end up with a negative 8 on this side. Over here, if x equals 1, I have the negative 5 minus 4 plus 1. I'm going to KFC this right away so I don't have to deal with that. Take care of my punctuation first. So negative 5 plus a negative 4. Same signs, add and keep. We have a negative 9 plus 1. Different signs, subtract. And I have negative 8 as well. Okay. All right. And so these are equivalent. Now, we know because we evaluated the expressions and they both equal negative 8. However, we can also explain why they're equivalent because of the properties. So if you look, one of the things that was done with these is we move, it's all addition, okay, if you KFC it all. And so technically we moved the x from like here to here. So you can see that commutative property occurred. So the commutative property of addition occurred. And then you can see the grouping change. So instead of negative 5 plus x, we have negative 5 plus a negative 4. Okay. And so we have the associative property of addition as well. Okay. So those are the reasons based on the properties why we already would know that they're the same. All right, that's it for this lesson. Great job.